This is TWiT.
Well, folks, it does it for that bite. I do want to move into the next bite because, a lot of organizations and people, they choose software based off of a couple things. The features, how useful it is, maybe how many users there are out there, maybe the performance, maybe its compatibility. But what about security? Not a lot of organizations choose for security. Curtis, what's going on there?
Well, one of the slogans in the industry is fail faster. But when it comes to software, shipping failed software isn't actually a good business strategy. You're expected to deliver high quality, secure software, and if you don't, it's going to be tough to realize measurable business benefits. So what do these terms mean, quality and secure, when it comes to software? Does good quality software automatically mean it's secure? And if it's really secure, can it be considered inherently high quality? Are they the same thing, or are they even related? Well, new research and even some legacy thinking says that it's complicated. But for CISOs and others responsible for ensuring security across software development, untangling a handful of questions is considered crucial. First, you have to define things before you can measurement. It's said you can't manage what you can't measure. You can't measure what you can't define. Quality software, well, that will execute according to intended design and purpose based on business functionality. Secure software won't put systems or data at risk of unauthorized access. Now, for many people, there's a clear relationship between the two, and one that's highlighted in guidance from the authoritative American Society of Quality, which positions security as a key element of software quality. Why is there any sort of tension between the two? Well, it's all history's fault. Ever since the days of linear waterfall-style development, quality has been the domain of development teams who didn't really have to think about security. That was the security team's job. Meanwhile, security worked separately and ended to bolting on solutions that might or might not be the highest quality. Now, whether you call it a quality problem or a security problem, fact is it's a problem. Humans make mistakes, and many teams just don't have the tools or capabilities to enable the creation of error-free code. Add in the constant pressure to move ever faster, and quality issues can quickly turn into security nightmares. Many breaches can be traced back to bugs, the ones that cause software to deviate from its purpose, or underlying quality defects like the failure to properly delineate code from data or sufficiently validate and filter input. Companies create software to fill a customer need, whether that customer is internal or external. That's software's primary business function. So some people say that there are 4 steps towards bringing the two closer together in something that the industry has called DevSecOps. Number 1, take a top-down approach. Security is everyone's job. That's the mindset. That's top-down. Involve security in developer training. For example, conduct post-mortem education, sharing source code repositories, and establishing authentication and encryption libraries that have security's approval. Embed consistent security across development, across the complete software development lifecycle. Monitor issues in a uniform, centralized way to make sure that the detection gaps are closed and everyone can see the full value of risk. Finally, take advantage of automation. Deploying automated testing on every code commit will help you catch vulnerabilities earlier and cut through the noise so developers can prioritize their efforts. Quality must translate into secure products if it's worth anything. And one of the things I want to do now is turn to my co-host Lou, you first. Does any of this resonate with you? Do you think there is an intrinsic relationship between quality code and a secure application.
Oh, absolutely. I think it's interesting because historically, I'm sure a lot of our audience can say, oh, yeah, I have a lot of applications and services that I use on my machines or in our servers that not necessarily the most stable, but are the most secure, which is interesting to say the least. But like you said, some of those quality problems can turn into security problems. Like, for instance, if an application over time crashes due to memory issues, well, then there could be an exploit that says, let me figure out a way to exploit the memory issue and crash the application. So, I mean, it definitely can lead to problems over time. But I've actually seen historically that sometimes the best, most secure applications, like you said, are not necessarily the most reliable all the time. And that's because they're always updating or moving forward very quickly. And I think that's the key, is being able to correct those problems and have an avenue to do so, whether it's service-delivered solutions or updates like a lot of modern applications do today, or constantly getting them updated to keep them secure. So that kind of avenue ensures that the reliability problems don't become security problems and that the security side stays secure. And I think that's that's basically the model that we're seeing from a lot of organizations out there, is they're focusing more on making sure their software is secure and that they have that avenue to update and keep them current iteratively.
That's important. The rapid iteration in so many modern development models. Brian, I want to turn to you because you've been involved on the security side for years. And I have to ask, when you were working in security operations, was software quality something that you had your finger on, or was that something that was seen more as the software development team's role while you looked strictly at the security issues?
Well, testing was a lot bigger deal when I was in that world. There's a lot of software that we were not allowed to use because it had not been blessed by the testing agencies. That's one of the things that I haven't been seeing in the private sector. It's like, okay, you guys are just going to order whatever you feel like, and we're going to do it. And we're going to commit a fairly major portion of your corporation to this. That doesn't sound like good planning. So I'm going to get back up on the testing soapbox and say, yeah, the federal government, the federal government hopes to try and do this all the time. It doesn't always, but it's something that needs to be done. Now, what I am going to point out is just because it's a security company doesn't mean it's going to be perfect. I'm not going to name names, but there is a particular home alarm system that managed to ship with a hard-coded diagnostic password that could bypass and allow anyone to shut down that home alarm system. And that managed to make it through, I don't know how many different layers of QA before it was released and sold many, many thousands of units all across the world. That kind of tells me that even the best laid plans sometimes can be tripped up by someone that forgot. So test, and more test. And the reality is there are many, many corporations that could do better, should do better. They're basically doing things that should have been caught but didn't get caught because the marketing guys pushed the product out too soon. Let's point fingers at marketing right now. There needs to be a better effort. There needs to be products that aren't going out with, a decade-old Linux kernel as the basis for their system. There needs to be people that are going to take the responsibility to look at security as a total package, the whole story. They shouldn't be building on decades-old Linux kernels. They should be using the latest and greatest. They should be applying patches. If it's based on open source, use those open source patches. And I totally agree with Curt in that just because it's secure now doesn't mean it's going to be secure a couple months down the line, because sometimes a patch gets through that has a flaw. We are all human. So yeah, there's going to be a lot of really interesting things. And I think the world in general needs to pay a lot more attention to quality control in their software and to make sure there are checks and balances that can be done by anyone in the QC process. Just like those emergency stop buttons on an assembly line. Everyone needs to take responsibility for it. Everyone needs to be able to stop the production when they find something big. And you just gotta go and bite the bullet, because if you're putting out product that someone's trusting and you break the trust, your company could go down the tubes very, very quickly.
Oh, absolutely. Well, my last question, Lou, is coming back to you. We've talked about defining the issue. And when it comes to defining quality, there are some formal systems for doing that, some frameworks. I think of things like the capability maturity model that came out of the work of Bill Curtis and others at Carnegie Mellon. Is that something that you see any value to when you're talking about quality in the context of security? Is that a useful way of defining quality when you need to talk to other groups?
Yeah, I think that's an interesting. A lot of these models are foundational. They're ways to use as a guide to really good software, to really secure software. But organizations have to implement these things, and some of them implement it differently than others, because a lot of these processes and models don't define on how you're supposed to meet those needs. And so the organizations basically translate that to whatever they can fit in. Like, for instance, what does that mean? Does it mean that you white box test, black box test, fuzz test, penetration tests? Do you use customer reports? Do you have feedback loops? What does that mean when it comes to formal processes? And so, there are some examples out there, templates, I guess you could say, that essentially help organizations with these formal processes. But a lot of times they don't always fit every organization. So I definitely think that these formal quality models really do help as a foundation. But again, an organization has to do right by what they think is good for their quality, for their service and their application. A lot of organizations nowadays are starting to use live data from customers, whether it's feedback from the customer themselves or it's getting them to agree to live data streams from their devices, their services, or applications to catch anything wrong with stability problems or issues, so that they can go and correct those things, especially when you have the P95 of those issues. And so, there's lots of ways to handle this, and I really think that some of these maturity models do help with the foundational. But again, focusing on what's working is probably another really good approach for this type of software and services.
Well, I think that having the variety of approaches to fit the variety of business cases is probably the right thing, as long as your business uses one of them. Pick one and use it. Don't just sort of throw code to the wind and see where it falls.